One consequence of all of these hidden relationships between trig functions that are trig identities is that some expressions involving trig functions, we can actually simplify them just by using identities that we already know. So here's an example, cotangent theta times secant theta. Well, since we can rewrite this expression using trigonometric identities, it's possible that we could simplify this expression so that it's nicer to look at, or easier to work with, or easier to evaluate. So let's see, what could we do to simplify this using identities? Well, if you think back to the sort of catalog of all of the identities we have available to us, one thing you can always do is write everything, right, all trigonometric functions in terms of cosine and sine. That's always an option. It won't always necessarily help, but it's always something you can try. And let's try it for this one. So cosine theta times secant theta, sorry, cotangent theta times secant theta. That cotangent is cosine theta over sine theta. And secant theta is, let's see, is 1 over cosine theta. And those are just basic identities about cotangent and secant. But now that we have it written this way, we can simplify these fractions. Those cosines are gone, and we end up with 1 over sine theta. But 1 over sine theta, that's cosecant theta. So that's one way we can use identities to simplify cotangent theta times secant theta. And the trick that we used was just to write everything in terms of cosine and sine. Let's look at another example of simplifying an expression by using trigonometric identities. So let's simplify this mess. Tangent theta plus 1 squared minus secant theta squared. It's a little harder to know what to do in this example. We could start out just by writing everything in terms of sines and cosines, but that would make an awful mess. It seems like at some point we're going to have to deal with these things that are squared. So let's try multiplying out all of the squaring first. So the idea we're using here is multiply everything, multiply things out, and simplify from there. Again, it's hard to see ahead of time if this is actually going to do us any good, but at least it's something we can try. So let's see, multiplying out this tangent theta plus 1 squared, that's going to give us tangent squared theta plus 2 tangent theta plus 1, and then minus our secant theta squared. There's not much we can do with that, so let's leave that as secant squared theta all over tangent theta. And let's see, seeing these squareds around reminds me of the Pythagorean identities. And since we have tangents and secants, let's remind ourselves what the Pythagorean identity is for tangents and secants. It's tangent squared theta plus 1 equals secant squared theta. And look, we have a tangent squared theta plus 1 right here. So together, those pieces give us a secant squared theta minus the 2, that's a plus 2 tangent theta, and then minus the secant squared theta that we had to begin with, all over tangent theta. All right. But now that we've used this Pythagorean identity, now I see, well, look, these secant squareds, those are gone. And then, now the only thing left is this middle piece in the numerator, 2 tangent theta over tangent theta, but this fraction simplifies. And we're just left with just 2. So this entire messy fraction, apparently it's just the number 2. So you can see if you have a big complicated trigonometric expression, it can really pay to put some work into simplifying it. You can imagine if we were going to try to use this big awful function as part of a calculation, it would be way easier to replace this with 2 and then do your big calculation rather than working with this big messy expression.